Draw the projections of a straight line capital AB 100 mm long, inclined at 45 degrees to HP and 30 degrees to VP. The NDA is in HP and the NB is in VP. Find the shortest distance between the straight line capital AB and the line of intersections of the planes of projection. So here, since NDA is in HP and the other end is in VP, so we have to start from the top view. So first we are going to consider B1 on VP and then draw a line which is inclined at 30 degrees to VP, and then measure the length of 100 mm and mark this point small a. Then since NDA is in HP, so draw a vertical projector. So when you look from the top view, we can see the inclination of the true inclination with respect to VP. So that is the reason why we have started from HP. So now NDA is in HP. So when you look from the front view, A dash will going to be on the horizontal line. So this is the front view NDA. So then he says the true inclination with respect to HP is 45 degree. So from A dash you measure in inclination of 45 degree and draw a line such that it will going to have the 100 mm length. So now we have got the locus of B in the front view and we have the locus of B in the top view. So now we have this point as B2 dash and this point as B1. Join A B1 with little bit thicker than the projection line, and here also A dash B2 dash which is little bit thicker than the projector line. So now this line is the true length in VP and this line is in true length in HP. So first we are going to find out the front view now. To find out the front view, now we have to consider the true length in HP. Since this line is in the true length in HP, so obviously that line is parallel to HP. Where do we find the parallel to HP? When you look from the front view only, we will see the parallel to HP. So B1, that is end B. So here B1 is in VP and NDA is in HP. So obviously when you look from the front view, that B1 should also be on HP because A dash is on HP. So A dash B1 dash should be on HP. But B1 is already on VP. So this is the case wherein A dash B1 dash is the line which is parallel to HP. Once you get this line parallel to HP, so you are getting the true length in HP. So but actually B1 dash is not on HP, but it is above HP by this distance. So with A dash as center, take the radius of A dash B1 dash, draw an arc such that it will going to cut the locus of B in the front view here. Then join A dash B dash with a dark line. So this will going to be the front view with parts that as B dash. So this is how we will be able to find. So once you get this B dash, then join with this A and this B. So this will going to be the line, actual line, it is in space. So NDA is in HP and the NB is in VP. Now we will going to consider to find out the top view now. To find out the top view, first we have to consider the true length in the vertical plane. So since it is the true length in the vertical plane, so obviously that line should be parallel to vertical plane. So NDA is in VP. So with A as center, take the radius of AB and draw an arc such that it will going to make parallel to VP. So now it will going to be true length in VP. So this is the, when you are getting the, when you have the front view or when you have the top view, you can do that. But now we need to find out the top view. So since this line is the true length in the vertical plane, obviously that line has to be parallel to VP. So we know this distance. So you project this point directly onto this locus which is A. So that AB2, this capital AB2 is the line which is parallel to VP. So how do we can do? So this is in space. So we are drawing a vertical projector here. So that means we are drawing a vertical projector. To do that, first we are going to consider this line. So this line which is above HP, so we are considering this line here. Draw a vertical projector from B2 dash to the XY line and then draw the from this point to the locus of A in the top view. So that this is the distance what we are considering here. So that AB2 is the line which is parallel to VP. So small AB2 is the line which is parallel to VP. But that when you look from the top view, that image will going to be false on HP. But B2 is not actually in front of VP, but B should be on VP. So with A as center, take the radius of AB2, then draw an arc such that it will going to be on the locus of B in the top view, then join AB. So that is what we have done. So once we have projected this, so it is made parallel to VP, but B2 is not in front of VP, but B2 has to be on VP. So with A as center, take the radius of AB2 and draw an arc such that it will going to be cuts the locus of B in the front view. So this point will going to become B, small b, when you look from the top view. So this is the line. So but here it will not be able to see that, because this is hiding this the line which is in space. So since we are rotating like this in space, so obviously the image which will going to get here will going to be this point, which is small b. So but we need to find out the shorted distance. So the shorted distance will be seen from the projection of points which will going to be on the profile plane. So for this we need to write the profile plane. So here we are looking from the left side view, so obviously we are going to take the right profile plane. So draw a horizontal projector from A to the xy line, so you are going to get A double dash, and draw a horizontal projector from B dash, so it will going to get this point here, B double dash. Then join these two with a dark line, which will going to be A double dash, B double dash. So A double dash is on HP and B double dash is on VP. So NDA is in HP and B is in VP. So you're going to get this line. Now to find out the shorted distance, we know this angle, we know this is 90. So 90 plus this angle minus 180 degree will going to give you this angle. So this will going to be the shorted distance. You measure that shorted distance, that will be equal to 40.82 when you are doing it in manual computer. When you are doing it in manual, it will be 41. So now the same thing which has to be done by using the sketchbook. First we will going to draw the xy line. So since one end A of the line is in HP and their end is in BP, so first we have to start from BP. So consider any point on xy line and mark that point as B1. By using the protractor, you measure an angle of 30 degree and draw an inclined line. By using the compass, take the radius of 100 mm. From B1, you cut an arc on this, so that you will going to get this point A and mark this point as small a. Then since it is the true length line, you mark it as capital B and mark it as capital A. Then since NDA is in HP, so obviously that image is going to be falls on VP. So from here, you draw a vertical projector to the xy line. You mark that point as small a dash. Then from A dash, you measure by using the protractor, you measure an angle of 45 degree and draw an inclined line. Since the true length is same in both in front and as well as in the top view. So with A dash as center, take the radius of 100 mm and cut an arc on this 45 degree line, so that you are going to get this point as B2 dash. Then join A dash B2 dash with little bit thicker than the projector line, and then draw a dash dot line which will going to be the locus line. So you have the locus of B in the front view and the locus of B in the top view. Now since we need to find out the true length in the vertical plane first, so first we are going to consider the true length in HP. So since it is the true length in HP, obviously that line has to be parallel to HP. So A dash is on HP, so B1 dash is also on to be on HP. So since B1 is on VP, so B1 dash and B1 both will be on HP and VP. So with A dash as center, take the radius of A dash B1 dash, because B1 is not on HP but it is in front, it is above HP by this distance. So with A dash as center, take the radius of B1 dash, draw an arc such that it will going to cut the locus of B in the front view at this point. So then you are going to get this point as B dash and join A dash B dash with a dot line. Now we need to find out the top view. Now to find out the top view, first we have to take the true length in the front view. Since we know that this is the true length in the vertical plane, so make that line parallel to VP. So since A is in front of VP, so B2 also should be in front of VP by the same distance. So draw a vertical projector from B2 dash to the top view. Both A and B2 are in front of VP by same distance with A as center, but B2 is on the VP. So with A as center, take the radius of AB2, then draw an arc such that B will going to be on VP. Then join A and B with a dark line, so which will going to be the top view. Then join between B and B dash, both will going to lie on the same line. Since we need to find out the shorted distance, so we need to write the profile view, draw the x1 y1 line at some distance, and then draw a 45 degree line adjacent to HP, and draw a horizontal projector from A to the 45 degree line, and then extend from here. So since A dash is on the horizontal xy line, so A double dash will also comes on the xy line. So draw a vertical projector from the top view B, then it will come to the origin, then you are projected upwards, and B dash is here, so you are going to get this B double dash here. Dark this A dash B dash, and then find out the shorted distance by considering measuring this angle. You know this angle is 90 plus this angle will give you to find out this angle, 180 minus of this angle plus this angle, that is 90 plus this angle will give you this angle. When you draw a line, So this is, it will go to intersect at this point. So then you measure this shortest distance, which will be 40.82 when you are doing it in computer. When you are doing it in manual, it will be 41 mm. So this is how we will be able to solve this problem in sketchbook. Now we will analyze this individually by first step. First we are considering B1 and draw a vertical, draw an inclined line in the true length in the top view. Then you project this, you are going to get into the front view, which is A dash. Which is A dash. Then you draw the 45-degree line, and for 100 mm you take the true length in the vertical plane also. Now we need to find out the top view. To find out the top view, with B2, draw a vertical projector from B2 dash, so that because it is the true length in VP, so obviously that line will be parallel to VP. So draw a vertical projector till to the locus of A in the top view. So AB2 is the line which is in front of VP by same distance. But he says the locus of B, but B is on BP. So with A as center, take the radius of AB2, draw an arc, so that B will be on XY line, so that it is going to cut the locus on the XY line. So mark that point and then join AB with a dark line. So this is the first step. So that is what we have done here. So we have considered this line and then you are rotated so that you are going to get this locus. So this is how we have done this first part. Now once you do this in the second case here, so this is how we will be able to get this point both, and then you are projecting this to the side view, you are going to get the shorter distance, and then this is how we will be able to solve this problem. And now here this is the front view. Now you are, so to find out the top view, so you draw a vertical projector from B2 dash to this AB2, you measure the angle, then rotate this so that B will going to be on VP, and then join this, you will going to get the top view, and then project this into the side view, you will going to get A double dash, B double dash. So this is how we can work out in the steps.